Alright, ladies and gents, this section we're going to be talking about trigonometric identities. So just like we have the additive identity or the multiplicative identity, we're going to have trig identities. So these are the ones that we've seen so far. We know that sine is the flipped version of cosecant and vice versa. Same through secant and cosecant and secant and cosine. We know that tangent is sine divided by cosine. We know that cotangent is cosine divided by sine. But these are ones that we might not have known so far. These are three identities that we'll be using for quite some time. So sine squared x plus cosine squared equals 1. Tangent squared x plus secant tangent squared x plus 1 equals secant squared x. And cotangent squared x plus 1 equals cosecant squared x. This video we're going to be proving these first two, and then your homework you're going to prove this one. Well, not necessarily prove, just show that it is true. So let's get started with the first one. Alright, so we're trying to show that sine squared x plus cosine squared x equals 1. And this is going to be true for any x known possible. So we're going to try and prove this. It's going to be helpful if we look at this as a right triangle, where the r is the hypotenuse and the x and y are the legs of the right triangle. Looking at that right triangle, we know that x squared plus y squared equals r squared. Okay, so already we're pretty close to this equation right here. The big difference right now is that we have equal to r squared and this one's equal to 1. So what I'm going to do, and this is perfectly allowed because I'm going to do it to the same thing everywhere, I'm going to divide everything by r squared. So now I'm left with x squared over r squared plus y squared over r squared equals 1. Now if you're looking at this as a strictly analytical point of view, we can rewrite this x over r squared plus y over r squared equals 1. Well, we remember back from when we were first talking about these trig functions, we know that cosine of theta equals x over r, and sine of theta is y over r. Now we can replace these things. So x over r is cosine, so cosine squared theta equals 1. And since addition is commutative, we can rewrite this. So sine squared theta is cosine squared theta equals 1. And there we have it. We just proved our first trig identity. On to the next one. We know that sine squared theta plus sine squared theta equals 1. And now we want to show that tangent squared theta plus 1 equals secant squared theta. So basically, I know what we want to end up with. We want to end up down here. And we have to start with something that we know. And we know that sine squared theta plus cosine squared theta equals 1. We know that to be true because we just proved it. Now we're going to try and make this equation look like this equation. So the big difference here is we have a 1 here and a secant squared here, and a cosine squared and a 1 here. So to make this look like 1, I'm going to divide everything by cosine squared. So I'm going to divide this by cosine squared. I'm going to divide this one by cosine squared. Oops. And I'm going to divide this one by cosine squared. So we have Alright? Now, we have sine squared theta divided by cosine squared plus 1 equals 1 over cosine squared theta. Now, eventually you're going to be able to make the jump from here to the ending, but right now I'm just going to show all the steps. So we know, so we got sine of theta over cosine theta being multiplied to itself twice over 1 over cosine theta being multiplied to itself twice. Sine of theta divided by cosine theta is tangent theta. Ooh, this looks nice. And 1 divided by cosine is secant. There we go. We just proved our second identity. Alright, for homework, I want you to prove this last identity. I want you to show that cotangent squared theta plus 1 is equal to cosecant squared theta.